help you understand that Kafka. We want to help you understand if Kafka could solve a problem in your organization. And number two, that you come away from this familiar then with the value and features of OpenShift Streams for Apache Kafka, including developer workflows, observability, and hopefully the demos will give you a better idea of all of that. Let's kick into it then. So I don't want to go into deep detail about Kafka itself. I think that's important. But the next two slides really just describe Kafka at a high level and the use cases where it is the right solution to a problem you're having. So I would highly recommend for anybody that's not familiar with Kafka and what it is as a messaging solution, read or Google this illustrated guide, right? Gently down the stream. It tells an illustrated story using otters, right? Like actual forest animal otters. So really easy to understand to explain Kafka and how it works. And I think it could be understood by anybody because a lot of people might see this new technology, might look at it and think some of the concepts or words that are used that people haven't heard of before might be a little bit overwhelming for them. So that's why something like this, I think, is a fantastic introduction for anyone to get into any type of new tool or technology. So I would highly recommend people take a look at it, and that really goes into more detail than what I'm about to. But Kafka, in general, this is from Apache Kafka's description itself. So Kafka is a distributed event store and stream processing platform. So I said I wouldn't go into Kafka too much, so that's a bit of a mouthful. But in simpler terms, it's a good solution for larger data sets, right? So when we talk about that distributed event store, it's able to scale horizontally. So it lends itself well to larger data sets or scenarios where real-time processing of events. So if you need to be able to process some event in real time, or events or messages is required. So that's kind of two of the main scenarios where it lends itself well. Kafka can achieve high throughput, millions of messages per second, right? So that's where we talk about those larger data sets with limited resources. And that's one of the scenarios that lends itself well. Unlike traditional messaging solutions, it's designed to also serve as a storage system. So generally with traditional messaging, once the messages are pushed out to the consumers, then they're no longer persisted in whatever that messaging platform is normally. But within Kafka, it's a log, and it stores a log of all the data that's there and can store as long as necessary, as long as you set that retention to be. Like I said, most message queues will remove them immediately after the consumer confirms receipt. So, and then the second part of that, what I described, distributed event store and stream processing. Stream processing is simply performing some processing action on data, such as analyzing, filtering, transforming, enhancing, anything like that in real time, rather than just passing messages along, right? So that's kind of breaking down what it means by that distributed event store and stream processing. There's other concepts on this slide that really is talking about Kafka itself. Again, it's here just more as an informational, but I really don't want to overwhelm people. So it's a very 1,000-foot view of what Kafka is in general. So then if we move on to, let's look at some of the areas Kafka can be the right solution for the job. And Kafka is ideal, like I said, at real-life data processing, large amounts of data, event tracking, and I think it's important to think about data as events because it can be a bit of an important mind shift. When we traditionally think about data in general, we think about classic example of a person, and they'll have attributes associated with them, such as name and first name, last name, things like that, right? Whereas within an event, it's more about think of what a person would do. So they might purchase something, that's an event, right? They might enter a store, they might do things like that. That is what we talk about from an event perspective. So it's not about the individual, but it's about the event that occurs. And I think it's an important mind shift because when we talk about that real life data processing, we talk, let's maybe step back, it might be a good example, to the origins of Kafka. So it's currently in the Apache Software Foundation, but it originated in LinkedIn. And where it came from is LinkedIn needed to rebuild its user activity tracking, right? Because it's real time, like publish, subscribe feeds, and LinkedIn is a very large platform. They have a lot of users. So they had that large data set of real time information that they needed to process and handle. So that's where Kafka came about. It was activity tracking. And when we think about that, it's like from an event perspective, it's a page click or it's a order or it's a follow, or these are all the types of events, the activity tracking that they were looking to do. So since Kafka persists these events, you can have several systems receive the data and process it. So you could have several systems consume that same data for monitoring, analysis, reports, news feeds, personalization, and so on, all of these different things. And that's where it came from, and that's what it can lend itself well to. So here's some other examples, right? So when we talk about digital experience, again, delivering real-time experiences with immediate access to information and response time. When event-driven architecture, like I talked about, so we have microservices, what a lot of organizations are doing these days. What's important in a microservices world is giving autonomy to individuals' teams to release that microservice independently. Otherwise, you just have a decentralized monolith, right? So loosely coupling microservices, and how you can do that is by having a messaging system like Kafka be that transportation of information between each of the microservices. So you can remain agile when you do that. Streaming, ETL, or extract, load, transform, so that processing, that lends itself well, right? Modern application driven by batch data, real-time processing for things like payments and all the other types of real-time events that need to be handled across a broad range of applications. Real-time analytics, you might want to, and we'll see a little bit of that in the demo today, ingest data from multiple sources for better business insights. It'll help your organization make more informed decisions faster. And then lastly, one of the example scenarios is edge and hybrid scenarios. So when we talk about edge is a big space, like even if we talk about the automotive industry, ultimately the cars are edge devices on wheels. That's what they are. So being able to keep them connected and communicating in real time, that's a large amount of information that might need to be sent as well. So there's a very diverse array of devices when we talk about edge and hybrid scenarios. But here's some of the problems that companies can have that Kafka can be the right solution for. So if you think that any of these things are something you might, some of the problems or some of the things that you might be tackling in the future, it could be worth looking at Kafka in my opinion. Okay, and for the next slide, I'll hand it over to Duncan.
Thanks, David. So yeah, what does Red Hat OpenShift Streams for Apache Kafka do in this space? So our product, ROSAC, or OpenShift Streams for Apache Kafka, is a fully managed cloud service, fully managed by Red Hat, that has a number of key characteristics where we think it stands out in the managed services market around Kafka. So first of all, the faster application velocity. We provide a opinionated way of deploying Kafka. Kafka has a lot of bells and whistles, configuration parameters, and ways of deployment under the hood, which can be intimidating and difficult to start with at first, and to actually run it at scale 24/7, high performance, low latency, high throughput in a high throughput fashion. So we provide a fully managed service that by a click of a button will give you our opinion way of deploying Kafka for enterprise workloads. The managed service also means that we are responsible for keeping that service up and running 24/7 with a 99.95 SLA to make sure that we update the service in case of new features or new implementations, bugs, security fixes, and so forth. We still give you a number of configuration options that you can control to deploy your Kafka or your topics on your Kafka instance in the way that you require. So, for example, whether you want to keep your data around for an X period of time, or whether you want your topics to grow to an X size. But a lot of the things, a lot of the more difficult configuration options and settings are handled by us. So the second thing is a unified experience across all clouds. There are more vendors that do this. There is also a lot of, especially hyperscaler vendors that provide a managed Kafka service that's very much targeted towards their cloud. our service works across clouds, or for example, AWS, Google Cloud, and whether you deploy it in one cloud or the other, the service experience is the same. It's unified. So you have the same console, you have the same web UI, you have the same CLI, you have the same way of working. So whether you run your applications in Google Cloud, whether you run your applications in AWS, maybe you run hybrid and you run or multi-cloud, you run them across clouds, the experience with Kafka, the way you manage it, the way you deploy your applications, the way you create topics, the way you interact with it is the same regardless of whether you deploy it. It makes it easier to build applications to get up to speed with the system. You don't have to learn a lot of different things. There's only one way of deploying, interacting with our Kafka service. And finally, the ecosystem around Kafka. So we have already spoken a bit about Kafka as a service. We provide more services than just Kafka that are related to Kafka. So an example here would be Service Registry, which is a platform in which you can deploy schemas that define message types and schema versions, and you can do governance over the types of events and message types that you're deploying to Kafka. So we have a service registry or schema registry managed service as well that you can use together with our Kafka service for schema and service management. Another example would be connectors. So it's great that you have a system that can consume events and to which you can produce events and where you can store events, but you need to be able to produce to that system, but also retrieve those events from that system and bring them to other environments. So our connector service provides a vast array of different types of connections that allow you to consume events from a source system and put them into Apache Kafka streams, and be able to consume events from OpenShift Streams and send them to other systems. For example, you could consume from an S3 environment and send it to Splunk, to give a simple example. So that's another service that we provide as well. Apart from that ecosystem as a managed service, Red Hat also provides something we call RAF, or Red Hat Application Foundation, which provides additional components and additional self-managed technology that allows you to interact with Kafka. For example, Quarkus applications, or your Red Hat integration camel routes that are able to interact with Kafka as both producers and consumers. Debezium as a change data capture platform is a great example of another piece of that Kafka ecosystem that Red Hat provides to build these event streaming solutions. Back to you, David.
Perfect. Thank you so much, Duncan. Okay, demo time. Let's hope this all goes okay. So the first demo that we want to do is just an overview, right? We're not going to deep dive into the layers of Kafka. We're going to show creating a Kafka instance and some of the other configuration that we have during that. Just to then create a topic and just produce and consume a message. Very simple concepts from a Kafka perspective. So let's get kicked off. Okay. Okay, so what you'll see here, actually, one second. Let me go back to our main homepage for console.redhat.com. So this is our hybrid cloud console for Red Hat, where you will see a lot of different managed offering, such as managed OpenShift and things that Duncan just mentioned, such as service registry and connectors. We're obviously just going to focus on OpenShift Streams for today, or managed Kafka. So I'll go into application data services, and immediately I have a try OpenShift Streams for Apache Kafka. So let's give it a shot. So I'm currently logged in with a user that is part of an organization where somebody, just so happens to be another user of mine, has already created a Kafka instance yesterday. So I'm able to view all of the OpenShift Stream instances that have been created by other users in my organization. But what I want to do now is I want to create a new one. And we'll switch back to this just while we're waiting for creation time. So 1 second. Sorry. Okay. This is the primary creation modal pop-up for creating an OpenShift Streams instance. And A couple of things that I want to go through here. So first off, we'll just give it a name, and you'll notice on the right-hand side that we have details that is ultimately just informational on all of the configuration details related to the instance I'm about to create. You'll notice that the duration is 48 hours. So what I'm about to create is what we are giving out for free. So anybody in the world can create a trial developer Kafka instance. It's a single broker, and as you can see here, very low configuration because they're trial instances. We also offer standard paid instances that live forever. They don't have a duration of 48 hours and a significantly higher configuration. We offer that in sizes for those standard instances, and you'll see that here. It's grayed out because it's trial and I only have the one configuration, but we offer a size of streaming units of 1 and 2 at the moment, which allow for greater configuration. And it goes from a 3-broker Kafka cluster to a 6-broker Kafka cluster with increased limits in the details that you can see here. I will show a little bit more about what those limits are in a moment, but we'll just create this first. That's number one. You'll see all the details that you have as part of your Kafka instance that we've created. Number two is we can choose cloud provider. Duncan said this. So at the moment, we support both AWS and GCP. So I can select either one of them at the moment to create my trial instance. And then we support, for trial instances at the moment, 2 regions, right? We support EU East 1 or US East 1 and EU West 1 for Ireland. But we also can support more regions. So if for our standard instances, if there's a region that we don't currently support, that there is an organization looking for whatever compliance reasons or whatever it may be, they require their Kafka instance or managed service to be in a particular region, absolutely come talk to us about that, and we can have that conversation to add an additional region in. For now, since I'm in Ireland, I'll choose EU West 1. I'll choose AWS because this trial, again, it's going to be just a single AZ, single broker instance. And that's it. That's the only configuration that I need to add when I create an instance. Simple, easy. And we'll notice here then that it's starting to create. So how long does that take? 5 minutes. The same amount of time that it would take you to go make a cup of tea. You will have your Kafka instance ready. Now, obviously, this is demo time, so I don't want us to have to wait the 5 minutes to be able to do it, but we'll come back here and we'll see that it will be ready once we've gone through a few of the other things. So the first thing that I want to do then is just go back over and give the overview. So this overview screen will give you the configuration for what I described as those standard long-lived Kafka instances of 1 streaming unit and 2 streaming unit. So in terms of what storage is available, the client connections that you're allowed, the connection rate, your ingress, egress. So they're the limits that you're allowed on that. It was significantly lower for our trial instances, but by all means, have a look at this if you're interested to understand exactly what the limits are and what our capacity is for each of the streaming units. Perfect. Okay, this will continue to create. So let's move over. And what we'll do now at the moment is we will go back to my other user that created this one. So very simply, all I'm going to do is just I just want to send a message. It's a messaging platform, right? I just want to send a message, and how can I do that? So this is an existing instance that I have. So the first thing that I want to do is I'll go into it. I'll have a look. There is already a topic there, which we'll go into in another demo. But the first thing I need to do in Kafka is I need to create a topic that I can both produce and consume messages to. So I can do that through the web UI. So that seems very easy. So why won't I? We'll just call it Open Demo Overview. What we're doing right now. Single broker instance, so we can only have a partition of 1, that's fine. Message retention, so exactly what Duncan was talking about. You can choose that configuration on a topic for how long I want those messages to last for. So we'll leave it as the default, that's fine. Finish, excellent. So that's our topic created, seems super simple. And then the next thing we want to do is we want to be able to produce a message. And how we do that, if we talk from a security perspective, we have service accounts, so that you will need to create to be able to then give access to produce and consume messages. Obviously, not everybody in the world, not all user accounts or service accounts are able to authenticate against your Kafka instance or be authorized against your Kafka instance. So the difference for maybe those that are not aware between user accounts and service accounts are intended to be for applications that are doing some sort of an action. Service accounts wouldn't be able to log into the web UI that I'm in here, and user accounts, which would be username and password traditionally, generally shouldn't be used for applications. You want a service account that's the purpose behind it. So let's do that, right? So if we create a service account here, again, we will call it Open Demo Overview. Perfect. Excellent. Done. So this is the client ID and secret, equivalent username and password for a service account that I just need to copy over, or else it won't be available for me afterwards. Give me 2 seconds, and I will copy that into my properties file I have on a different screen. What I'm going to do is I'm going to use very simply just the Kafka scripts that are available from Apache Kafka themselves to produce and consume messages, and we'll see that in a moment. So I'll copy those over to a separate screen. That's perfect. So let's try and produce a message. Our existing Kafka instance is there. We've created our topic that we want to produce a message against. So let's give it a shot. And caveat, what we will see is because obviously I have not authorized the service account, I haven't granted it access to be able to do that, we will see errors. So what you'll notice here on the screen that I'm sharing on the terminal is you will notice a couple of things. I'm using the Kafka scripts, just a console producer. I am specifying the same topic name separately. If we go over to this, and
David, one comment. I think you made a typo when you created the topic. I think you used the letter V in overview.
Good catch.
Thank you.
Right, I appreciate that. Let's have a look, and we'll get it again. Oh, I did in the name.
No,
indeed.
that's the Kafka instance. No, you made 2 typos. That's the Kafka instance. Go into that one and look at the topic name.
I will. Thank you so much, Duncan. I just want to point out first, it's been 5 minutes. My cup of tea is ready, and my Kafka instances that we created 5 minutes ago is now available. So in the amount of time that it will take you to boil a kettle and make a cup of tea, if that's your preference, or coffee maybe, your Kafka instance will be available and ready to use immediately. So let's go back in and let's check that I did indeed. Thank you very much, Duncan. So I indeed did miss a W. So let's correct that. We want to produce against this. And then we have some configuration. So this producer config at the very end is where I copied my client's ID and secret from my service account. And then you'll notice this here, this bootstrap server. So obviously we need to specify the URL, the public domain of our Kafka instance. So question, where do I find that? Well, good question. We get it from our Kafka instances ourselves. So if we go back to our main Kafka instance screen, if we click on the row, we'll see the details of the Kafka instance, including the Kafka ID, the owner, which is myself. And then if we go to connection, we'll be able to get that bootstrap server URL exactly from the connection info that I've now copied over. Since this instance existed already, I had it prepared beforehand, but that's where it's available to you. So very simply, we will produce a message. So I am now connected. I can produce my first message on this new topic.
David, could you make the font a little bit bigger?
Oh, of course I can.
For me, it's unreadable. Thanks.
So as expected, is that better, Tom?
Yeah.
Excellent. So as expected, we got a not authorized to access this topic because we never granted that service account permissions. So let's go back and we'll do that now and we'll retry. So how can I grant access to a service account? Very simply, from the web UI, you can do it. You can do it from the CLI and other places as well, but it's as simple as that. So, we created that new service account called Open Demo Overview, and we want to add it permissions. So what do we want to give it? Well, we want to give it a topic. We'll say, it's the misspelled Open Demo Overview, and we want to we'll give it all permission because we want to produce and consume on that topic. And sorry. Perfect. That is now done. So if we go back to our terminal and we try again, we will see that we are now able to produce our first message. Perfect. And then separately, if we want, let's see if we can consume a message from that topic. Let's do it in real time, actually. So, sorry, 1 second. Windows are not working out too well for me. So we come back, we will start our producer and we will start our consumer. Apologies. Of course, my topic is misspelt. Okay. So there is no, our service account is not authorized. Authorized to consume messages.
I think you're missing.
Let's go back and we'll have a look at our authorization rules. Permissions on everything for now. Purposes. Okay. As you can see, we have very simply, all we've done now is we have created a Kafka instance. We have created a topic. We created a service account to be able to use with our bin scripts that are here. We've granted access to that service account on the topic, and we've simply produced and consumed the message. Very simple in terms of that, but that's how easy it is to get started. And if we go back to our main screen, again, we can see that that instance that I created 10 minutes ago was ready within the 5-minute time frame. And that's how easy it is. Those trial instances are free for anybody in the world to create today. You can play around with Kafka the same as what I just done. Duncan is going to go over into more detail on developer workflows and how to use some of the other automation and integrations that we have with Rozak. That's exactly what it is. And then if you think to yourself, well, I don't really know exactly what you just done. How do I even know? I'm not going to remember those steps. Good question. If you go to your learning resources that are here, these are all the learning resources that we have for all of our managed services, but even just filter for OpenShift Streams, they're all there. There's learning resources with the amount of time that it will take, the same as what it did for me, of how to get started, including, you will see there is one here for the Kafka scripts that I just used that will run you through the exact same thing. There is also learning resources here for using a Quarkus application with your Kafka instance and other things. So if you were worried about not being able to remember exactly how to do all of that, it's simply in our web console available to you to view at any point in time. And you can create a single developer instance per user that you're logged in at from console.redhat.com. Okay, perfect. So if we go back to our slides then, I'll reshare and I'll hand it over to you, Duncan.
Yeah, thanks, David. And I think I need to take over the screen in a minute. So yeah, what David just shows is a very easy way of getting started with OpenShift Streams for Apache Kafka. You can quickly create a Kafka cluster or an OpenShift Streams instance, as we call it, quickly create topics, ACLs, all through the web UI. But there's other ways of interacting with our service, and we provide a number of different tools and utilities focused mostly on developers and on administration as well to for example, use a CLI or Ansible automation to provision and interact with your OpenShift streams in your Kafka instance. And also the applications deployed on OpenShift. Obviously, again, you want to interact with your Kafka service. We provide tools and utilities around deploying, for example, Quarkus applications to OpenShift and integrating them as producers or consumers with OpenShift Streams for Apache Kafka. So I'll give you a couple of demonstrations or some simple or maybe not so simple things actually to work with Apache Kafka using OpenShift Streams on a daily basis as a developer. I'm going to try to share my screen. David, can you give me a shout when you can see that?
That's great, Duncan.
Oh, that's awesome. Good. So, yeah, same overview as David, but I'm in a different organization, so I don't see his Kafkas. He doesn't see my Kafkas as intended. So I already have a OpenShift Streams and Kafka instance deployed here, which is called Samurai Pizza Kafka. So it's the name I always use because I find it funny. And this one doesn't really have anything configured yet. So there's no topics. There's very little access control, basically the defaults that you get for your user account when you create a Kafka instance. So there's not much there, just an empty Kafka instance. So what we want to do first, what I want to show is a bit of the CLI. So we provide a CLI called ROS, Red Hat OpenShift Application Services. And with that CLI, you can not only manage Kafka, but also the other services that I mentioned earlier. So things like service registry and connectors in the future as well. But let's focus on Kafka for now. We can do a ROS Kafka list. Hopefully I'm still logged in. I'm still logged in, which is great. So here I can see that I have an OpenShift Streams instance here. It's deployed on AWS in US East, and I am the owner, which is great. I can get a bit more information about that. Well, let's first say that to my command line that I want to use that Kafka instance as my default Kafka instance. So I do ROS Kafka use. I select the Kafka instance that I want to use in my current context, which basically makes sure that every command I do against the Kafka will be executed against this OpenShift Streams. So now I can do a ROS Kafka describe to give me a bit more information about my Kafka instance. So I can see, excuse me, the admin server URL, the bootstrap server, the cloud provider, when it was created, and a number of other configuration settings as well. I can see that it's a trial instance, the storage size, etc., etc. So this is all great. I can also create topics through the CLI if I want to. I'm not going to do that right now because we can use something else, but we can do something like that ROS Kafka topic create. And then I can create a topic. I can specify the number of partitions I want, the retention time, retention bytes, etc., etc. Again, great if you want to set up a Kafka instance quickly and you want to create some topics. But if you need to do things repetitively and in a controlled way, for example, with a script that you store in your Git repository and you're doing GitOps type of workflows, there's other means to manage your Kafka instance. So one of the things that we provide is an Ansible collection, which is available on Galaxy. Which is called Red Hat OpenShift Application Services. Again, it's an Ansible collection for all of these services that we provide, including Kafka. And this allows you to create an Ansible playbook and Ansible scripts to create Kafka instances, create service accounts, create topics, create ACLs, basically all the things that David just did via the web UI, but now in a scripted way. Because I'm lazy, so I'd like to write a script and automate myself out of the equation. So let's look at that for like right now and see what we can do. So for example, we can create Kafka instances. That part is somewhere here where I can create provision a Kafka instance or a ROSAC instance via the create Kafka Ansible module. But since I've already have a Kafka, I don't need to do that anymore. But what I do want to do is I want to provision a number of topics. So here's a module to create Kafka topics with different configuration parameters and so forth. There's a loop setting here because I want to create multiple topics. So I can just create one little script and loop through a number of topic configurations, which I've defined here at the top. You can take my word for that. It's there. But I can also create service accounts. I can create ACL, so the access control list that we showed to give access to these service account to certain topics or certain consumer groups and so forth. So this is all based on the Red Hat OpenShift Application Services Ansible module that you can find in Galaxy. There's a documentation there on how to use that as well. So let's give that a go. So I'm here in this directory where I have my Ansible file here. There's also two JNinja, I think it's called JNinja templates that actually export the service account credentials. So what David just copied, when you create your service account, you can your client ID and client secret. I wrote a little script in Ansible that actually pushes that into a local file in the form of environment variables and one in the form of an OpenShift secret. So it can easily apply that to an OpenShift instance later. So I'm going to run that Ansible playbook like so, and then we're going to pray to the demo gods. It finds the Kafka instance because it can do a check whether Kafka instance is already there, and it will not create one twice. It creates the topic, it creates a service account, it sets the ACLs for the topic, for the consumer group, and the transactional IDs, and it's done. This is all fantastic. I can't even make a cup of tea in that time, so you'll remain thirsty while you are actually working with Ansible. So let's go back to the UI, and let's go back to my instance, and if all is well, we can see that there's now 2 topics here, which is fantastic. I can also see that via the CLI, so I can do rows, Kafka, topic, lists, and that will give me those topics as well. And I can also see that the ACLs have been created like so, and they've been set for my new service account. And I know that this is my new service account because my little Ansible script also created 2 files, one for my environment variable and one having the client ID and secret in a OpenShift secret. So this is all fantastic and it works. This is great. So now I've got my topics created. I've seen the CLI, I've seen Ansible. So let's see if we can actually deploy an application. Now, because we're deploying application, obviously we're deploying on OpenShift because we want to create microservices in containers and what have you, and make sure that it all runs in the cloud. So we've got an OpenShift environment provisioned earlier, which is running here. There's a project called OpenShift Streams for Apache Kafka Quarkus, so we're deploying a Quarkus application. And as you can see, there's no deployments here yet. So what we need to do, I actually grabbed the Quarkus Kafka Quick Start and added a number of configuration parameters for it to interact with OpenShift Streams. So what we've done is, let's see, this is the processor. Now I need to produce our application. We have a Quarkus application here, and we added a number of configuration parameters for it to work with OpenShift Streams. So we specify the bootstrap server, which we get from an environment variable in OpenShift. We specify the security protocol, the SSL mechanism, and the client ID and client secret, because we need to have credentials to connect to the Kafka cluster. So this is all parameterized. There's no hard coding here for these settings because these things just got created through my Ansible script. But now I need to create a container out of this. So we are using, well, I am using Maven clean install, and we tell the Quarkus plugin of Maven to push the image to my image registry. I hope I'm still connected here. I haven't tested this. If not, it's still there because obviously I did this before the demo yesterday. So it's creating a container now and it's pushing that to Quay. When we now look at Quay, so Quay is our container registry, container repository that provides us Red Hat, where you can deploy your containers to your application containers and from the registry deploy it onto an OpenShift cluster. So here I'm in the Kafka producer, Rosa Quarkus Kafka producer registry. And here, let's see, it has not been updated yet. Oh, yeah, see, I'm logged out. There is no connection. So I'll skip this for now. It's because I forgot to log into Quay before I was running this demo. Apologies for that. But you have to take my word for it. I did this yesterday, that there is a container image now in Quay here. So once we have that, we can start deploying the application. We go back to the CLI because what we would want to do is that we need to get the information, for example, our Kafka host and the bootstrap server configuration, etc., into our OpenShift project, and we want to do that as a config map. So a configuration map, which is a map of configuration parameters for our application. So to make that easy, we've got a generate config command here where you can generate your configuration for your OpenShift Streams for Apache Kafka environment in, for example, environment variables. but also as a config map for OpenShift. So we create that. And as you can see, we now have a config map, an OpenShift config map that contains the Kafka host that it got from the Kafka context that I've just shown. This is the bootstrap server URL of our Kafka instance that our CLI now generates, or the config map that the CLI generates. So we can apply the config map to our OpenShift environment. And it's been created. So what we now need to do, we also need to provide the client ID and client secret because the application needs to connect to the service as well. So as you see, we've just generated that with Ansible. And now we can say OC apply -f. We give it the secret. And that creates the secret in our OpenShift project, as you can see here. So with the configuration parameters, so the bootstrap server host and the security credentials added to our OpenShift environment, we can now deploy the application. And because we like to do that automatically as well, we've been using Ansible, we've been using these generated files, I would like to use something like Helm to actually deploy our application. So I've written a little Helm, if I can find it, a little Helm script, so to deploy both the producer application, the producer application, the processor that is going to retrieve the messages from Kafka, do a computation and send a message back to this producer. Basically, it's a quotes application, so it does a quote request. The producer does a quote request on the quote request topic. The processor grabs that message, creates a quote, and sends that back to the quote topic for the producer then to consume and get that quote. So we're also creating an OpenShift service because we want to expose that web UI of that application, and we create an OpenShift route so we can actually access it all through Helm charts. And what we provide in the producer here is, as you can see, we provide the Kafka host, environment variable, the service account, the secret, to be used by our application, and we retrieve that from the config map and the secret that we just deployed. So let's see if Helm wants to collaborate today. We do a Helm install. So we run that Helm script, and it's already done. So now we can go back to OpenShift, look at our deployments, and as you can see, we've got 2 applications deployed already. What we can also see is that it's actually getting those environment variables, those values from the config map and from the secret that we've just created through our CLI and through Ansible. And now if we go to our service, our route actually, we can go to our quotes environment. We can request a quote, which gives us a message that says pending, and then the other application retrieves the message and gives us a quote. And to show you that I'm not cheating, we can go back to Red Hat OpenShift Streams. We can look at the quote request here. We can look at the messages, and we can see that there was a single message for a quote request. And then we can go back to the quotes themselves. So here we can see there was a quote of $49. We can go back to the quotes topic. We go to messages. And here you can see that we have a message with a JSON payload, which has a price of $49, what we just saw. What we could also do, if we don't like to use the web UI, we can also use the CLI to say rows, Kafka, topic, consume, and we say quotes. And if that all works correctly, we can actually retrieve that message through the CLI as well. So, little recap. We had nothing. We used an Ansible script to automate everything. We created topics, we created service account, we created ACLs. Then we created the secret with Ansible as well from the service account we created. We created a config map using the CLI from the Kafka description, the Red Hat OpenShift Streams instance description. We pushed the config map and the secret to OpenShift. We created a container out of our Quarkus application, pushed it to Quay, used Helm to deploy it, and we can see messages flow from our applications to Kafka to another microservice, sending a message back to Kafka and back to the quotes, and all being able to monitor and see those messages through the web UI and the CLI. And I want to shout out to the demo guys. Thank you very much, except for that one single error, but you have to take my word. Back to you, David.
Pretty amazing demo, Duncan. Thank you so much. Okay. What I'm going to do is we have one last quick demo. I'm conscious of time. I understand that there's only 11 minutes left. So the very last thing that I want to talk about, I'll only spend 2 minutes on it, is observability, and very quickly show the output of that. But so Duncan's demo was amazing. We got to see exactly what it would look like for an organization to stand up clients, consumers, and producers in an OpenShift environment, connecting to a ROSAC, an OpenShift Streams instance. It's pretty amazing. Now, once you have all of that in place, and as an organization, understanding that there is another company that is managing the OpenShift Streams, the Kafka instance for you, obviously there's major benefits of that. Red Hat will be responsible for the maintenance. Red Hat will be responsible for actioning any alerts if anything goes wrong. That maintainability, operability of it, of the Kafka cluster itself, is what Red Hat takes on board. However, as an organization, you may want to observe your own Kafka instance, some of the metrics that are required for that, because you're not deploying it to your own infrastructure. You don't have access directly to configure all of that stuff. So what we do as Red Hat, we provide you that. We provide you ways to be able to view metrics and to be able to observe your own OpenShift Streams instance, both through the web UI, as well as giving you the option of a REST endpoint to be able to view those metrics. And for those of you that are familiar with Prometheus, a federate endpoint, you can actually scrape user-facing your own metrics from your ROSAC Streams instance directly into your own Prometheus instance. You can scrape them, and then you can create dashboards with Prometheus as a data source, whatever you want to do. And that's exactly what I'm going to show you right now. Okay. So the first thing that I'm going to do, just so we can see how exactly this will work, I just want to produce some load against that same Kafka instance I created earlier. So again, I'm just going to use the Kafka performance test, but we don't need to worry about it. I have a throughput of 8 messages a second, a certain message size and things like that, but we're not going to worry about it too much. And I'm going to consume them on the other side just so we can see some of the dashboards. But I want to go back to, so what I have set up here and what I'm about to show you is, I have a managed OpenShift instance, OpenShift dedicated here, and I have a Prometheus instance deployed and I have a Grafana instance deployed. So what I've done is I've already set up a Prometheus scrape configuration to scrape the metrics from that federate endpoint for the metrics associated with that ROSAC instance we saw earlier. And not very great to just look at the metrics. So what I will show you is I will show you the Grafana dashboard that has been created that you can use yourself. This is available to you in Grafana Labs, so you can use this Grafana dashboard to view the metrics associated with your instance. What you just saw there is real-time metrics, real-time metric. I just started producing and consuming messages. There was nothing showing in this dashboard. It's refreshed every 5 seconds, and then we're actually seeing the incoming byte rate. We're actually seeing the incoming message rate. We're seeing the used disk space, the log size. We're seeing everything in real time as I am running these performance scripts that are producing 8 records a second of a certain size, and I'm consuming them on the other side. It's as simple as that. So it gives you the ability to be able to observe your own ROSAC instance so you can understand it better as to how your own clients and your organization are producing messages on exactly what topic. This Red Hat OpenShift Streams for Apache Kafka Grafana dashboard is available out of the box for you to use. And there is also a blog post from Duncan Dial himself advising you and running you through the steps on exactly how you could set up a Prometheus scrape configuration and be able to gather those metrics into your own Prometheus instance. Okay, and with that, the very last thing that I will say is how you can try it. So red.ht/try Kafka will bring you to the developer page. where you can read more about OpenShift Streams, where you can click on the link that will get you to the screen I showed earlier and Duncan had showed to be able to create your own Rosac trial instance that you can play around with today. And that's it. Thank you very much, everybody. Joanne, is there any, so I'm not sure if there's questions already or if there's any, or exactly how you want to handle that now. Do we have time for questions?
I think Juan's on mute.
Yeah.
But there is a question, which is how is this priced?
I can take that one. So it's we price this in different ways. We've got different models that we can use. So one model that we use is a prepaid pricing, which is more like a traditional